Today we are going to be looking at distinct objects distributed between distinct people, and the question we're going to look at is the JE Main Shift 1 April 2023, the number of ways of giving 20 distinct oranges to 3 children always deemed to be distinct, such that each child gets at least 1 orange is. That's the question we're going to answer, but these other 3 questions, alternative question 1, 2 and 3, we're also going to answer. Alternative question 1 we're going to answer because this is the way most people incorrectly answer that one. Question number 2, which is the number of onto surjective functions from a set of 20 distinct elements to a set of 3 distinct elements, is identical to that question. It's the same question, and we've already dealt with surjective onto functions in a previous video, how to count surjective functions. And the alternative question 3 is basically just an easier version of the JE Main, where we don't have the constraint that each child gets at least 1 orange, and that is extremely simple to answer. Okay, so let's have a look. First of all, let's have a look at alternative question 1, which is the one that most people think is how to answer the actual question, and it's simple stars and bars, and we've done that before in a few videos, Gresty Academy videos. So basically we have 20 identical oranges, 3 children, each child gets at least 1 orange, so give each child an orange, and that leaves us with 17 oranges to distribute between 3 children, and we do that by using the formula which we've already discussed in previous videos, n plus n minus 1 c m minus 1, which is 17, add 3 minus 1 c 3 minus 1, which is 19c2, which equals 171. That is what people answer when they think they're answering that, and it is incorrect. As you will see, the actual answer to this is a multiple of millions higher than that, because we're looking at distinct oranges rather than identical oranges. Okay, so that one basically is how to do question number 1. Alternative question number 3, by the way, let's just do that one quickly. It's actually very simple. If we got 20 distinct oranges to give to 3 children, well, basically the first orange we have 3 choices of which child to give. The second orange we have 3, the third we have 3, and basically as there's 20 oranges, there are 3 to the power of 20 possible ways that we could distribute the distinct oranges between the 3 distinct children. So that's alternative question 3. So now actually let's have a look at the question which we're supposed to do, which is the JE Main 20 distinct oranges to 3 children, such that each child gets at least 1 orange, which is exactly the same as the surjective, counting surjective functions, which means that we're going to use the Stirling number of the second kind multiplied by n factorial, which is, it does look a little bit horrific this, but in actual fact it's quite simple. Minus 1 to the n minus j, ncj, j to the m, where m is 20 and n is 3, because there's 20 distinct oranges and there are 3 distinct children. And when we plug in all of that, basically we get 3 to the power of 20 minus 3 times 2 to the power of 20, add 3 times 1 to the power of 20. All I'm doing there is just plugging in j equals 0 to 3 into this formula here. And that is actually the answer. So the answer to JE Main, how many distinct oranges can you give to 3 children such that each child gets at least 1 orange? The answer is 3 to the 20 minus 3 times 2 to the 20, add 3. That's the answer. Now, just a matter of interest, if you looked up in a table the Stirling number 23, and you can look it up in a table, that number equals 580606446, which is 580,606,446. If we multiply that by the number of children factorial, which is 3 factorial, we get this answer, which is 3,483,638,676. So you can see that the number of ways of distributing 20 distinct oranges to 3 children, such that each gets at least 1 orange, is substantially more than the number of ways of distributing 20 identical oranges to 3 children, such that they each get 1. Hope you found this useful. Please don't fall into the traps. If you did, please press the little thumbs up button to like this video and subscribe to the Greci Academy YouTube channel. Thank you.